Good afternoon, everyone. Thank you so much for joining us today. I'm assuming that you guys are here because you're interested in learning more about Arduino education. I am just going to give it probably another minute or two to see if we have any stragglers that are joining us. Normally when I do these, there's always a few people that kind of trickle in afterwards. So we just want to give them an opportunity to join. And in the meantime, I'm just going to introduce myself. My name's Kristen. I work with Spectrum Educational Supplies. I've been with the company for over 10 years now, and I specialize in technology sales in Canada. I oversee Ontario and I support our regional team. Quite a few of our regional team members are actually here with us today. So I'm just going to highlight them by name. So we've got Marianne. She helps me out here in Ontario and really focuses on the daycare market. We also have Kim Schick, who looks after BC and part of Alberta. And then we have Colin Gilmore as well. So he looks after Manitoba, Saskatchewan, and the other part of Alberta as well. So I'm pointing out some of my team here today so that if you are outside of Ontario, if you're in one of the other provinces, there is a dedicated rep for your area. I am going to put my email address in the chat box today in case anyone wants to reach out to me directly, and I can always put you in touch with your regional rep, or you and I can start a conversation. I do recognize some names on our call today as well. I'm super excited to have you guys with us, and for those of you that are here for the first time, welcome. You will notice that I'm kind of looking back and forth between two screens. So just so that you guys know, I'm totally engaged and paying attention to you all here. It's a lot of things to manage. So I find the two screens really help me out. So hopefully the stragglers have now had an opportunity to join us. Again, welcome. And without further ado, I do want to welcome Roxana and Nerea from Arduino Education. So they're actually going to be presenting today and sharing all that Arduino Education has to offer. They're going to be introducing us to some of the products as well as some of the benefits to implementing Arduino in the classroom. So I just want to turn it over to you guys. I will stop sharing my screen now and allow you guys to take it away. Thank you.
Thank you, Christine. I think we need permission to share the screen, right?
No, you can do it now.
Perfect. There you go.
Yep.
Yeah, you can, but I can't. Right? So, well, maybe you can just pass, Rox, if you want.
Okay. Well, you give it a try and let me know if you can. Or
okay, now I can. It said no before.
Great.
Yeah, you can see it, right? Perfect. Well, welcome everybody. Thank you for being here today. It is a pleasure for us to be in the first webinar about Arduino education in Canada. So we'll try to give you an overview of what we do and what type of solutions we have been developing in the last years. So both my colleague Roxana and myself will be with you today for any questions. I mean, we'll support each other in the chat and so on. And of course, also, we want to thank the Spectrum team, Chris, and the whole team for arranging the webinar and for joining us into our family. So Spectrum is our educational partner for Canada, meaning that locally is the company that you can contact for any doubts or any supplies you might need from our side. So we have established the relationship in order to bring all the training and support and products that we have developed to the Canadian market. I am Nerea de la Riva. I am currently the education partner sales lead. And Rox, would you like to introduce yourself?
Yes, thanks, Nerea. I am Roxana, and what I do is like I have a really close relationship with our educational partners and conduct like training so they know about all of our education offering.
Mm-hmm. Yeah. And we are actually based in Sweden and in Spain. So for us, it's here around 10 p.m. So you notice something weird, is because it is a bit later for us. Good. So let's start with the basics. We just would like to give you a quick overview of what is Arduino, right? Arduino is an open source platform. We call it platform because it includes a lot of things. It's not a board, it's not a programming environment, it's everything. It is a platform that contains hardware, software, documentation, and community, right? The fact that it is open source, it means that everything that we develop inside of Arduino is something that we share with everybody. So the design of our boards, how our programming environment is done internally, all those source files are shared for everybody to use them, to learn about it, to improve them, and to then later on share it with others, right? Our goal is to allow anybody to innovate by using our technology, and for that we aim to make complex things easy to use. Our worldwide community is built of makers, students, teachers. We have all type of people in the community, more like entry-level experts that support each other and so on. And the community is so big thanks to being open source, right? So that's part of what it made us grow. Our community is even bigger than our company. We have more people in the community than employees. So that's how we make it. And when it comes to Arduino, actually, it was created by these 4 guys that you see in the picture. They are all teachers. So we always say that Arduino comes from education and it is for educators. And therefore, that's why Arduino Education. The first research was done at the Interaction Design Institute in Italy at Ivrea. And the idea was to teach a group of students that didn't know anything about technology, how to create interaction design projects and so on, right? So they needed to know the basic of electronics and programming, but of course they didn't have any background, right? So what these guys made, it was to create a platform that was easy to use, that was kind of plug and play, the same for the hardware and for the software, and they just shared it, and other teachers saw it from other universities, and then they started to use it, and they started to order this platform, right? And that's why Arduino converted into a company, and that was 16 years ago, so it has been a while ago. Then with the years, actually, we identified different type of users and different segments that, even though will use the same tools, they will use them in a different way. So therefore, inside of Arduino, we have 3 different verticals. One of them is education, which is the one in which we will be focusing today, and it's called Arduino Education. Then is the maker one, which is the one that started first, which is a bit more for enthusiasts and people that wants to do things on their own. And then we have a vertical that is for professional development, more connected to the Internet of Things, and that's towards the industry, right? So that's more advanced, and is the one that you will see, the last one. Normally you will start getting a little bit of documentation and training from the educational part, and you will become a bit more like maker. You will create your own things, and then later on you will be able to connect it to an industrial application. That will be more or less the path that a user will follow, right? So let's focus a bit more on the education vertical and what we do for teachers and students. But before going into that, let's just give an example of all things that you can do with Arduino. This is so that you can get inspired. There is actually, as part of our community, there are many things like the forum, the discussion, and so on. But there is something called Project Hub that you see here in the screen. So if you want to get inspired, you just Google Project Hub, and you can search what type of projects you want to see. You want to see a robotics project, or I don't know, maybe a smart greenhouse or something like that. So you can just, or space, whatever category you want, you can just search, and you will find different projects done by the people in the community that will inspire you to create your own things, right? So that's so that you get inspired and know how far you can get with Arduino. And when it comes to Arduino Education, this is a little bit what we do. Everything that we create is aligned with curriculum. We always focus on STEM, so we try to align our products with these subjects. For us, what we have created is a learning platform, and again, it is a platform because it follows the same philosophy as the Arduino overall. So we are providing hardware, software, community, content, and everything together. Everything that comes in the kit, everything comes in one kit. We will see more details about that later on. And we focus a lot on the 21st century development. So the idea that we have is that students are able to explain what they are doing, not that they are just following a set of instructions, but that they are also creative, that they learn in a collaborative way, that they develop their soft skills and so on, and that they are able to do much more than just follow an instruction and maybe put together a circuit, right? Everything that we do is project-based learning. You will see that there is just a few theoretical parts in the online platform, but most of the things are actually done through a project process. And of course, I mean, our strongest area is the training and support for teachers. That's why we actually partner up with local teams like the one in the Spectrum that know your needs much better, because they are there and they understand the curriculum and can help you out maybe better than us from anywhere in Europe, right? So that's a summary of what we do in Arduino Education, and our portfolio looks more or less like this one. Each one of the things that you see there is a different solution. Today we'll try to give you an overview of the different solutions. We'll focus a bit more on the ones that are ready for the COVID-19 context, because there are some of them that are more like classroom-based and imply collaboration. So in some places they can be used, but in some others they cannot be used. So we'll focus a bit more on those that are ready for hybrid learning, meaning that it can be done in the classroom or it can be done at home. Our portfolio currently covers from middle school all the way up to the university. And when I was saying before that everything needed comes in one kit, is because, of course, I mean, you will choose one of the programs, and whenever you receive the box, you will see that, of course, the hardware is there. So the electronics, the Arduino board, everything you need to build experiments is there, but also the IDE is included. You can use it offline or in the web editor, and you don't need to install it. But if you want to use it offline and you need to install it, you just download it for free from our website. So it's not an extra cost in order to program the hardware that you have bought. It's just for free, the software. Also, you will get access to an online platform. Later on, we'll show you a little bit how it looks like. This online platform contains exercises both for teachers and students, as well as a training course and all those things. And then finally, there is also a support that you can access from the online platform, and you will see later there is like a couple of clicks you need to do in order to get direct support from us. So that's what we offer, the full solution. And of course, we focus a lot on the learning by doing. That's our maker spirit, and we think that students and teachers can learn much more if they try to do an experiment with the different things, right? Yeah, and we have summarized there a little bit the things that we focus when it comes to 21st century skills. Of course, it's the critical thinking, the problem solving. So what your circuit is not working, why your program is not working, and so on. We always try students to work in groups so that they are able to assign different roles and to communicate with each other, and the flexibility aspect as well. Good. All our solutions are focused in different tools. So yes, we'll make an Internet of Things kit, but all those will come with an Arduino board. And we just wanted you to have a quick look at the Arduino boards. This is just a few of them. These ones are the ones that are included into the educational solutions. So the most famous board and the one that was developed was, the first one is the Arduino Uno Rev 3, but we have evolved, of course, and right now we have boards with all type of connectivity, Wi-Fi, Bluetooth, boards that are bigger, smaller, that are able to be integrated into a small project, or that probably are bigger, like this one here, that is able to connect to an IoT cloud and get data from anywhere and just show it at the screen and so on, right? when it comes to boards, we also have shields and carrier. These type of boards, what they do is that they expand the capabilities of the core boards. So they actually complement what the motherboard is doing, and they add some extra capabilities. In the case of the education shield, for instance, it makes it easier to make the connections, right? So in every Arduino education kit, you will find always Arduino boards, and depending of the complexity of that kit, you will find a basic board, or you will find a more advanced or complex board that will perform other tasks. With these boards, you could even do machine learning and artificial intelligence application and so on. Good. Together with the boards, we are speaking about the software and programming environment and so on. The Arduino web editor, or the Arduino offline editor, looks like this one. This one here is the offline editor. Once you install it, you will see that it comes with a lot of preloaded samples that you can use directly to get started with Arduino, and the same applies for the online version of the IDE. Also, when it comes to the IoT applications, so Internet of Things, we have our own IoT cloud, meaning that you will be able to program your dashboard, and that could be, for instance, a smart house that you have created. So with an Arduino board, you could connect your lights from your home to this system, and maybe you are outside, but you could from your phone switch the lights on and on, off and on. Sorry. So basically, you will do like a smart control device. And thanks to our cloud, you can do it directly, and there is a step-by-step documentation on how to do that. So these are some of the software that comes together with the educational kits. We have speak about the online learning platforms. The access to the platforms is the same for all the educational kits. You always will start the path from the box. Once you have the box, on the lid, you will find a unique code and a URL, and with that you can access the online platform. You have to create an account. If you're a teacher, you will be able to create an adult account, and you will have access to the exercise solutions and teacher guides and lesson plans and all that. And if you're a student, you will create a junior account, and of course, I mean, everything is compliant so that there are consent and the children are safe and so on. So depending on your age, you will create one type of account or the other one. And with this account, you can access all the online platform. You have to create it just once. Once you have created your account, you find the activation code, you click next, and basically your kit is registered, and you will get access to the online platform. We will see now one of the solutions, and the solution that we will see now have some online content, so we will be able to see what type of content and how to use it. So the first solution in our portfolio that we will see today is called Arduino Student Kit. It's an entry-level kit. It looks like this one here. It is recommended for 11 years old and up. Basically, it's ready for individual use. So it is a small box that comes with materials for one student. It is ready for blended or hybrid learning. So if they are at the classroom, they can use it in a safe way. They don't need to share it. But also if the situation changes and they have to go home, basically they can put it on the backpack and they can bring it home. The learning outcomes of this kit, we will see more in detail, but basically it's an introduction to electronics and programming. You don't need any previous experience. And once again, we have very present the 21st century skills. We have it available in different languages as well. And if you want to have a preview of the content, more or less it looks like this one, but we will see in the slides a bit more in detail. Let's see if it grows. Well, now it's in Spanish because I have been using it in Spanish. I'll put it into English. Yeah, so this is the preview of the activities, more or less. You could enter the student kit one, and here you will see a sample of one of the lessons, right? Maybe we can put in the chat the link, Rox, of this one, if you can, so that you can access it later and have a look at how the lessons looks like. But coming back to the slides, let's focus a bit more on the key learning goals of the student kit. Here we have summarized more or less what the students and you as a teacher will learn, but basically you will learn the different variables like the current, voltage, and resistance. You will learn different programming concepts like loops and charts and how to make a diagram, how algorithms work. Also, you will learn the difference between digital, analog. You will also learn how to use a multimeter. You will also learn how to use a few electronic components and the difference in between inputs and outputs. How do you read an input? How do you apply it and make an output work and so on. We will also see an introduction to microcontrollers and all those type of things. And of course, the Ohm's law and so on, right? So this is more or less a summary of what it is in the content. In the content, there are 9 lessons and 2 open projects. When we say open projects, it means that we have put some sort of guidelines, but the students are the ones that will decide how to finish this project. So with what they have learned in the lessons, they have to be able to create their own projects. So they have to come up with an idea, they have to document that idea, make a plan, and be able to actually make it work. Also, the code is done on the online platform. So this is an entry-level kit. That's why all the coding experience will be done. But at a certain point, whenever they hit the open projects, they will need to be able to take the different functions and make them work together. The code is done, of course, but in every lesson we ask them to modify it. So in every lesson we will ask them to modify a different parameter, and then we will explain them why that parameter works this way or the other, so that they start first learning about how the code works before they can actually start coding themselves. There is also within the content a section called Invention Spotlight. That section actually put them, the students, in contest. So it actually gives them a little bit of information on, okay, if this is a resistor, how was the resistor created and by whom and when and in which context, right? And then there is a student logbook in which they can, it's a PDF, so they can print it and they can fill the different exercises. And there is a teacher guide with the solutions and also with the advices on how to use this kit in the classroom. There is a vocabulary section with all the definitions, and there is training material and also support. So basically, if you click here on the question mark, you will be able to contact our support team at any time that you need. When it comes to the hardware, since it is an entry-level kit, you will see that it is based in one of our basic boards, and also it has a bunch of sensors and actuators like the servo motors or like light sensors and so on to make the different project works. Since it is the first kit that you will see, if you have no idea of, about electronics and coding, there is also a multimeter that that will allow the students to take different measurements in the circuits and start understanding how they work. And when it comes to the software, even either the offline or the online editor can work with this kit. Let's see a little bit more how to use the content. So once you access the platform, you will see that as a teacher, you can, if you click on the eye at the platform, you will have the teacher view or the student view. You can download the logbook. In that logbook, you will see the exercises for the students and so on. All the lessons are prepared to last in between 90 and 135 minutes, more or less. The open projects are a bit longer. So there are actually 10 chapters. The first one is the intro, then there are the lessons and the projects, and the chapters 5 and 10 are the projects. So they will make a few lessons, then an open project, a few lessons, and then an open project. So they will start making projects with what they are learning in the guided lessons. The lessons are built so that they have to follow them in a linear way from the first one to the last one. And also the students' logbook, as I said, is a PDF, so they can just print it and make the exercises once they are done with the lesson. And that's it. We have the answers also for the exercises in case that you need them. Also, the teacher notes are this thing that appears here highlighted. And as I said before, you can either activate or deactivate the teacher notes by clicking here. So if you don't need them, you can deactivate them, but you will see that maybe there is a question that you don't know the answer. In the teacher notes, you will find the answer, or it will give you advices on, at this point, maybe you should explain this or that, or make sure that the students use it this or that way, or at this point, students always get confused with this other concept. So the teacher notes are really, really useful, especially if you don't have that much experience with electronics and coding or using this type of solutions at the classroom. there are advices about everything, not only technical advices, but also about the methodology in the classroom and so on. And that you can do just by activating the AI. Also, there are further notes. The blue ones, you can see it, but also the students can see it. But the teacher notes, if you have a student account, you cannot see them. And with the further notes will teach the students a little bit more, so it will challenge them a little bit. Also, the lessons have all of them have a similar structure, so that they are easy to navigate at the online platform. You will always find the estimated time, the key learning goals of the lesson, an overview. There will always be a material list. So the lesson structure, you will see that it's all the time the same. So it should be easy to follow. And this is an example of an invention spotlight that I have told you before. So in this case, we're speaking about electricity, and we will tell them about the creator of this concept. And then when it comes to support, if you need any type of support, you just click on the help or on the question mark button, and there you will find a contact form. You can select different categories about the problem that you are having. And if you're not able to, if we answer and we are not able to succeed with the answer and you need a connection with us or a webinar, we can also set that webinar and make sure that you get the support that you need. Finally, if we check at the, how is it called, the students logbook, here you have an example of the different type of exercises that the students will find. The first lesson or the introductory lesson is about safety. They are going to work with electricity. I mean, of course, it's really small, the amount of power that they are going to use, so nothing should happen. But there are a lot of recommendations on how to use and how to work safely with electronics, right? So then after they have go through the introductory session, they will land into the students logbook and there will be a quiz. There is a quiz or an exercise for each one of the lessons, and this is an example of how they look like. And when it comes to the projects, we have said that there are 2 open projects, right? And that the students can decide how to finish those projects. There are some guidelines, like you have to use 2 lights and 3 keyboards. So there are some guidelines, but the students will be the ones deciding how to create that project. And in order to assist the teachers during the open, for the open projects in the teacher notes, there are suggestions on how to actually score those projects to see if the student have passed the challenge or not. So you will find there that there are several categories that we advise you to evaluate when the students finish the open project. These are 3 examples of the guided projects. One of them is a traffic light, so they will learn that whenever you click the button of the traffic light, either the green, the blue, the green, the yellow, or the red light will work in a different way. In this case, they are learning about a series of parallel circuits. They are learning a lot about how a breadboard works. They will learn about the different components and how to use them, and of course the programming part as well, right? They will learn how to read the status of a digital input, the difference in between input and output, and all those things. This one here is a timer switch. So basically with this potentiometer here, you will turn it and the lights will switch on or off depending of the value of this potentiometer here. So it is like a radio or something similar. So it's the same kind of device. And then this one here is a keyboard. So it has 1 button for each one of the notes. And whenever you click them, the speaker will make a different type of sound, right? So as you can see, this one is quite simple. This one gets a bit more complicated because of the analog signals. And later on, we end up doing a bit more complex projects in which they use a lot more components and the programming part starts getting more and more complicated. And that has been the entry-level kit, the student kit. So I don't know, Rox, if you would like to continue from here with the second one.
Of course. Thanks, Nerea.
You're welcome.
Thank you. Just quickly, I will change and I'm going to present share my screen. All right. So I'm going to talk, to share with you the other solution we have, which is the Explore IoT Kit. So this is one of our other focus products. It was designed for students 16 years and up. You can use it in the classroom or also at home. If you want to use it in the classroom, we recommend for 1 kit, 2 students, no more than that. And the goal of this kit is for the students to have a really good understanding of the basic concepts of IoT in an easy and a very quick way. So they will learn how to investigate, they will explore how data works when they gather data from different sensors and how to manage it from different devices. And this is very important because when they understand this kind of technology, we also make them aware about privacy and how data is managed. So those are very important aspects when we are talking about the Internet of Things. And for this particular kit, we need, or it's preferable that the students have a little bit of experience in programming. So you need the very basics, so you don't need to need a lot, but it's good if you already know or you are familiar with the Arduino IDE, with the software and how you program the basics, right? And the kit is available, or the learning platform is available in English and Spanish. And here are the key learning values. So as I was mentioning before, the students will learn how to control different objects, different sensors. They will learn how to collect data from different sensors, how to store that data, how to interpret it, how to analyze it, and how to back up it. They will see it will be very useful for them to see data in form of a graphs. So they will also learn how to do that, how to collect that, and how to visualize it with graphics. They will learn also about APIs, JSON, and web servers, of course, network security. The board we use for the Explore IoT Kit has a crypto chip, so all the communications between the board and our cloud are safe. And they will learn how different sensors work, like temperature, humidity, light sensors, all of that. And I will show you now how the board it looks like. So first the content. So we also have an online platform, in this case with 10 activities and also 10 challenges. We also have the code here, explained, commented, so they understand what it's happening and how the code works. And also we have all the lessons with all the concepts explained, and of course support for the teachers too. In the terms of the hardware, we use the Maker 1010 board, a Maker IoT Carrier that, as Nerea mentioned before, it expands the capability of the board, and also you can do a bunch of stuff with the Carrier. And it comes with 2 external sensors, a PRA or infrared sensor that sends movement, and a humidity sensor. And for this kit, we use the web editor and also our IoT Cloud, which makes everything easier. Sometimes when you want to start with learning IoT, it's hard because you need to use different things. So here, you don't need to worry about that because you have the hardware and the software. So it's very easy. So this is a Maker Carrier that was specifically designed for this kit. And although the kit comes with only 2 external sensors, as you can see, the Carrier have 5 inbuilt sensors. So we have temperature, humidity sensor, pressure sensor, light, gesture, and proximity sensor. So you can do a lot of IoT cool experiments with the Carrier. And if you turn the board, the Carrier, you just connect, like put the pins into the Carrier, and then you expand the capabilities of the board. So it also has a piezo there for sound. And as you can see, it uses growth connectors. So everything is plug and play, because we want that the students are focused on the learning and not spending too much time with connections. So they just plug and play, and that's it. And so the online platform has everything you need to know and to learn from IoT. Every lesson is about 45 minute long, including the challenges. The challenges are also around 45 minutes. We also have the teacher tips, like the icon Nerea explained before. So you just click on that and you will see a box with extra teacher tips and good things to know when you start implementing this or you're learning yourself about the kit. And for every lesson, we have well, at the beginning of the program, you will see a getting started lesson on PDF. You can download it, and it will give you a really good overview of what are you going to learn with this kit and the things you need to take into account or be aware when you implement this with your students. And also we recommend that you proceed in a linear way, so you get familiar with the basic concepts and then you start applying those concepts into the next lesson and so on. And as you can see, all the learning platforms have the same or very similar layout. So you have the navigation menu here. And here we have on the other side, on my right side, we have an introduction of the lesson, estimated time of completion, learning objectives, and you will see the step-by-step tutorial for every lesson. And of course, at the end, you will have a challenge. So we know that when we are working with the students, they have, some of them learn faster than others, or some of them already have some previous experience. So that's why we have the challenges there, because the idea is that all of them work at the same time. It's not that one team finish and they're just waiting. So everyone is working at the same time. And then this is like the learning flow or the steps you need to follow when you work with the IoT cloud. So first we create a thing, which is the board, the physical board. And then we create some variables that we want to measure, like it could be light, temperature, etc. And then we start building our dashboard to monitor in real life the data that we're getting for the different sensors. And we can create and customize our dashboards the way we want. It comes with different widgets, so that's very cool. And also to make things easier, when you start establishing the variables, the IoT will generate part of the code. So it's even easier for you to start programming what you want to do your activity. And this is how the dashboard looks like. So in this example, we have a dashboard that is that has the humidity and the temperature, light, and some of the relays that also include the carrier. And another cool thing that students really like is that we have a remote IoT app that you can download on your phone. It's free, it's available for Android and iOS. So you can also monitor from your phone what is happening with your cloud. If I'm not at home, but when I want to get at home, I want blue lights, I can do it with my phone. So when I get home, I have my blue light. So this is very interesting for the students. You can remotely control what your IoT setting that you have. And this is how the projects look like. As I mentioned before, there is not that many connections, just like growth sensors, and that's it. So we have 10 lessons, and here we're showing the remote trigger lesson, the urban farming 101, of course, the greenhouse. The greenhouse is very famous in the IoT, so we have that lesson. And also we have an international weather application where you connect to a server and you start getting the weather information from different countries in real time, and you will display that information on the carrier display. And the last focus product we want to show you is the Arduino Engineering Kit. So this kit was designed for students we recommend that students from 17 years and up using it. You can also use it in the classroom if you would like to do that. And if you want to do so, we recommend 2 or 3 students per kit. And this solution, the goal is that the students will learn all the key engineering and mechatronic concepts. They will learn about robotics, image and video processing, etc. And this kit was designed in collaboration with MathWorks. I don't know if you are familiar with it, but it's a very well-known software platform used in most of the engineering universities. So we collaborate, or together we design and build this kit. And it's a hands-on tool, and the same as the others, and also the platform is available in English and Spanish. So these are some of the key learning values that students will learn. So they will learn about system modeling, control theory, basic or fundamental concepts of robotics, mechatronics, image and video processing. They will also get familiar with MATLAB, MathWorks, and Simulink, the visual programming, simulations, analyze and visualize the data. And also what is very interesting about this kit is a part of that they will use or learn to use MathWorks, MATLAB, and Simulink. And this is the online platform. It comes with 3 lessons and 3 projects. In this case, you can follow the program or the lessons in whatever order you like. So you can start with, of course, it's good to go through the lessons first, but when you come, when it comes to the projects, you can choose whatever order, whatever project you want to build first, it's fine. We use a Nano IoT 33 board. It's a smaller board. We use a Nano motor carrier because in this solution, every project moves. So this carrier helps with the connection with the motors. And all the components and assembly pieces are included. And of course, we're going to use MATLAB and Simulink basically during the program. So in case you don't know what MATLAB is, it's a high-level programming environment. So, and the interesting about MATLAB is that it's widely used in the industry and also in the academia. So it's very important for students to know how to use it and get familiar with this kind of software. So as you can see, it's used in many fields, different fields, and also the skills they get and also the task and the activities they will find in the kit has this connection with real life. So that's very important when you are learning these kind of skills. And the content is modular, and as I mentioned before, you can follow it in whatever order you like. It's very flexible, so you can adapt it to depending on the class or your time. You can do it, and the navigation it's very easy. We have some videos that show how to assemble every project, and the project takes around 45 minutes to assembly. So we recently improved the content and the navigation to make it even easier. And this is one of the first projects, or one of the 3 projects that comes with it, in the kit, is a self-balancing motorbike. So the students will build it, programming, and because the motorbike actually works, right? So it's not a model that you just show there, it works, it moves. So they will learn about kinematics, feedback controls, model-based design, and the interesting thing here using MathWorks and MATLAB and Simulink is that they will be able to model the system before actually deploy it in real life. So that's very good because they can model the system, make the simulation, and when they're ready, when they like how the model works, they deploy it. And the other project is this one is a webcam control rover. So this rover will be a web control with a webcam that also is included in the kit, and you program the rover to move to different following a different path and lift the object there, the forklift. And of course, they will learn about image processing, simulations, Wi-Fi communication, etc. And the last project is a drawing robot. So again, the students need to build and program the drawing robot. So in here, they will scan a picture or whatever image they want the robot to draw. And they will program it to draw the image. So this is a very interesting project. And also, what I forgot to mention on the other kit is that when you finish whatever Arduino Education program, it doesn't mean that that's it and you won't use it anymore. So you have the knowledge, you have the material, you have the hardware, you have the code. So many students keep experimenting with what they learn. They sometimes modify an existing project or they build their own. So everything, the hardware and the parts, everything is flexible, so they can keep experimenting as further as they like. So that's very important. We have, in this case, in the engineering kit, many students that have built different things based on that. So they have built some applications, and for example, for the rover, there's a video of students controlling the rover with a phone, with an app that he built. So they can still working on once they finish the programs. So these were our focus products for now that we are on COVID, so they can work when you are at home. But we also have classroom solutions. And these classroom solutions, Arduino, as Nerea mentioned at the beginning, it's all about collaborating and learning in teams. So these solutions that I'm going to show you are for the classroom, and the idea is that students work together in teams and they collaborate. So this is the Education Starter Kit, and it's exactly the same as the first kit Nerea showed you, which is a student kit, but this is the classroom solution. So one of these big kit is for 8 students, and the teacher would divide the class on 4 groups of 2. So you have 2 students working together. So the only thing the teacher needs to do is give one of the boxes you see there, one board, one shield, one multimeter, and they start working in teams with the projects. But it comes also with the same learning platform as Nerea mentioned. The only difference here is also that the teacher invite or register or enroll the students so they have access to the platform. But the rest is exactly the same. The projects are the same. But again, this is a classroom solution. So here we have the comparison between both of them. So again, it's similar, but here we have the pieces and the hardware for a classroom. And the next classroom solution is the starter kit. Probably, if you know a little bit about Arduino, probably you have heard about this. This was designed originally for makers, but we saw that teachers use it in the classroom. So we include it in the Arduino Education portfolio. And also because we saw that many teachers were using it in the classroom, we create a classroom pack that has 6, here, 6 starter kits for a class of 12. And this is for students 14 years and up. And the difference between this starter kit and the other education starter kit is that this starter kit, we don't have a learning platform. It comes with a projects book, because as I mentioned, this was created more for makers. So it's also a really good kit to get started, but you won't find these deep concept definitions and explanations and descriptions that you will get with the student and the education starter kit. And also an important thing about this is like it's available in many, many languages, as you can see, but also the projects are a little bit more complex than the student kit. So here we can see the difference between the Arduino Student Kit and the Starter Kit. So the main difference, as I mentioned, is that the Starter Kit comes with a projects book. The projects are a little bit shorter because here we don't have that fundamental concept details about electronics and programming. And the last solution I would like to share with you is the CTC Go program. So CTC stands for Creative Technologies in the Classroom. And this is a very cool program. It's a STEM modular program. So the teacher will be able to choose or design their own STEM path. So we start with this program with the core module. And once this core module has all again, the hardware, the software, the learning platform, and you will learn all the fundamentals of coding, programming, and electronics in a hands-on way. And once you learn that, you can pick one of the expansion packs, depending on what you want your students to learn. So if I'm maybe a physics teacher, maybe I would like to have the motions expansion pack. So in that sense, it's very flexible because then as a teacher, you can pick what expansion you would like to teach to your class. So let's take a closer look to the core module. So this is for older students from 14 to 17. So we have the content, it's a little bit more complex, and also the concepts. And one kit is good for 24 students. And again, the teacher would divide the class in 8 groups of 3. Again, the teacher gives one of these boxes. We call this system the management, the classroom management, and this makes the teacher's life easier because they just give one box, one board, one shield, one box with all the pieces, the plastic pieces to build the projects. And every box has printed all the materials and the components. So when they're done, they know exactly the number of pieces that needs to go back to for every box, so the teacher doesn't get crazy. And also the learning platform comes in Spanish and English. And the platform has 8 lessons and 8 projects, and it's basically the same learning approach. You will see the coder, teacher tips, training and support. For this kit, we use the Uno board, but with the Wi-Fi Ref 2, an education shield to make all the prototyping easier and faster. All the electronic components are the modular pieces are included. And you can use it with the Arduino IDE offline or with the web editor. And this is the kind of projects that the students can build. And again, once they finish with the program, because of the modularity of the pieces, they can improve one of these or they can build one of their own. We have some teachers that organize like fairs or contests or something like that with the students to encourage them to keep exploring and building things. And the first expansion we released last year was the CTC Go Motions expansion. And it's for the same age group. It has the same methodology. One kit is good. It's good for a class of 24. And here the students will learn how to add mobility to their project. So everything is about motors, how to make things move. And the online platform in this case has 4 lessons and 4 projects with exactly the same layout, the same approach. And this is the type of projects they will build, 4 projects. And as you can see, we have modular pieces and we have motors, so they will learn how motors work, how to connect, and how, as I mentioned, add mobility to all the projects they build. So that was it. I don't know if you have any question. I know it's a lot, but if you have any questions, just please feel free to ask. And thank you so much for listening.
Yeah, Natalie has a question. Go ahead.
I have a question. Actually, I have a question about the online editor, because is that relatively new? Because the last time that I worked with the Arduino, they only had the desktop version that we could use with the starter kits. So when was that added? And is it, I guess one of the biggest challenges that we had with using the Arduino with our classes that a lot of students would rely on the school computers, and we weren't able to install the IDE software on the school computers. So when it came to the coding piece, they were a little bit out of luck. We had 1 computer, 2 computers that we could have the software on. So just could you tell us a little bit more about the web editor and how that works?
I'm not sure, Nerea, how long it has been there, but we have done many improvements to that. So the only thing you need to get started with the online version, it's install a plugin. So you just type Arduino Web Editor and your browser will tell you to install a plugin, and then you start working with that. It also includes library, and I really like that because when you are working with the IDE offline, you need to connect your board and then you go to tools and select the board and select the board. The IDE, the online IDE does it for you. So it automatically recognizes your board. You don't need to to say, oh, this port and that port. Also, it has a library. And what I also like about it is that you can share the code. There's a button said share. So you can share the code with whoever you want. Your students can share with you, or you can share that with the teachers. You can add comments to the code. So the sharing part, it's also easier. And also there's a tab where you will find with some examples that already comes with the offline IDE, some of the circuit like fritzings there. Some of examples have the illustrations, but it's basically the same. And also the cool thing is, like, if you're interested in IoT, you can work together and the integration is really easy. So it's really cool, actually. I really like that.
I was very excited to see it because that was one of the stumbling blocks with allowing us to implement it widespread within our classroom, was the fact that we couldn't get the students to edit unless they had the device with the downloaded IDE. So I guess it's been 2 years since we looked at it because we haven't been in school to try it with the students. So I haven't actually, pulled it out to do it with the kids this year. But so that was really, I'm really happy to see that. Thank you.
Yeah, just you can take a look and try it. But it's really cool. Thank you.
I think we got time for a few more questions. Does anybody have any questions that they would like to ask?
Oh, we were super clear.
I have another question, just out of curiosity. So if we already had starter kits, so if we've got a class set of starter kits that was purchased a couple of years ago, what would you recommend be sort of the next addition to kind of take it to the next step? Like, what would you suggest be the next piece?
How old are your students?
They're high school, so 15, 16.
So maybe they can use the IoT Explore IoT Kit.
Okay.
So you know the foundations, right, of Arduino. So that would be interesting for them.
Okay, thank you.
No, Nerea, what are
No, I was also thinking that, Explore for the Internet of Things, but also the CTC Go could be great for the mounting and more like project based. And yeah, I think both of them, CTC or Explore, could work.
Anyone else? The floor is open. Feel free to ask questions. Okay, well, if nobody has any more questions, I'm just gonna steal the screen for one last thing. Thank you.
Thank you.
Oh, moved everything on me. All right, so we're gonna be doing a draw for a student set.
Ooh.
I have everyone's names here. I'm just gonna shuffle them a couple of times and let's see who our winner.
Good luck.
I know, it's exciting.
Yeah, woo! Oh my God.
Asma, congratulations.
Just for this, you won.
So I just put my email address in the chat like I promised. Please reach out to me either today or sometime tomorrow and provide me with your address and I will get a student set shipped out to you.
Congratulations.
Yeah, we did have some questions earlier about pricing. So if you're in Canada, oh, Grant had a question though. I don't want to miss that. Are there plans to build a kit around RP 2040? And he put a link to 2040.
Yeah, that's our latest board. Yeah, it might be. We cannot tell.
I can't tell yet. It's a secret.
Yeah, it's a secret. We always make or try to make educational kits around any of the solutions that we launch into the market. So there is a possibility. Yes, we will. I mean, and thank you for saying so, because that's also feedback that if it's interesting for you, of course, we should look into it.
Exactly. But yeah, we have new kits coming, so just keep an eye on the
Yeah.
site so you see what's coming up next.
That's the thing with technology, right? There's always new things that are in the works that not everyone can always talk about right away. So the last thing I'm sharing on my screen is spectrum-nasco.ca. You can visit us online to check out any of the Arduino products, as well as under Spectrum Educates on our website, you can view any upcoming webinars. We have some Lego webinars coming up. We're doing an introduction to Spike Prime June 16th, that's next week. And we actually have a Lego Q&A coming up as well. So just keep an eye on our website to see what new webinars are coming and what partnerships, we're going to be partnering with different companies to bring different products to you guys. So thank you very much for joining us today. And I hope everyone has a wonderful rest of the week and a great weekend. Take care, everyone.
Thank you for tuning.
Thank
Take care.
you.
Bye.
Thank you, Christine.